This is officially week 14. Our plan is to go over some of the new material related to Java generics. In particular, I'd like to talk about maps and sets that are available from the library, and also some issues related to generic algorithms that we can apply to our collections. For example, like sorting. We already mentioned sorting earlier on, so we're going to talk about the possibilities of using the sorting for our collections. As you know, in CIS 123, we went over extensively over some sample sample code for the final project assignment. And so this will be posted either tonight or tomorrow morning. I'm actually planning to post it tonight. So keep in mind that there's this conversation that you can always refresh your memory on. But today I'd like to focus on new material. So let's see. We will open the presentation for the collections again. And as you recall, we went over a conversation about ArrayList class, and we tried to use ArrayList in those CIS 123 demo sessions. Then we mentioned that there is also a list class. The list class is very similar to an array list, but it manages its memory differently because it keeps track of individual elements based on object references, whereas ArrayList stores object references in Java array in a more primitive structure. So we said that linked lists may be helpful if you work with collections where you need to insert and remove elements in the middle of the collection, which may become a better performance, give you better performance results. So we briefly mentioned linked lists. I don't have any homework associated with linked list, but it's very similar to ArrayList. It's just that internally the storage is managed differently. The interfaces are very, very similar. So I'm going to try to skip that, and let's first look at some of the algorithms available for Java. For example, if I type Java collections, class, and do the search, there is a utility class named Java collections. And similar to what we saw with arrays, if you recall, there was utility class named arrays, which gave you a chance to do binary search, sort of our arrays. Similarly, this particular class, utility class, gives us access to all of these algorithms such as binary search and copy and producing some set operations such as disjoin, for example, which we will talk about later on. Fill is there as well. But obviously, there will also be something useful like reverse. You specify your collection, and you can reverse the order of elements. So very useful collection of algorithms such as rotate or shuffle, things like that. And there's, of course, sort. So today, we're going to talk a little bit in more details what sorts do internally, what popular sorting algorithms do exist, and you may have already heard about the bubble sort, but it's typically not used because it's very inefficient in terms of the performance. But just to give you a heads up that this very useful collections class is available, and as soon as you start using generic collections such as ArrayList, uh, the linked list or any kind of map, you can immediately get access to all the functionality that this particular class gives you. And it's very useful because it will, instead of writing your own custom sort algorithm, you just do it in one line, basically saying collections.sort. We may actually try it later on if we have time to try it today, or maybe next time, maybe Thursday. So anyway, but it just gives you a heads up. But today, like I said, let's take a look at the algorithms for for searching and sorting. And interestingly, they're both connected because sometimes you can speed up searches by sorting your elements inside your collections, inside your sequences. So the search algorithms will simply, the straightforward approach for search would be to check every element and compare that element with particular value. And this most likely is going to look like a long loop in your program where you just do your comparisons. If you find an element that you're looking for, you just found it and you can proceed with that. Or if you didn't find it, somehow you need to signal the rest of the program that the element wasn't found. So that's just a straightforward approach to search. And this is called sequential search. So statistically, when you have collections, and if you approach to execute searches through your collections often in your application, most likely if you base your logic on a sequential sort, the result is going to be that sometimes the elements that you're looking for will be located closer to the beginning of the collection. Sometimes they will be located closer to the ending of your collection. But on average, the average time you spend doing those searches will be somewhere in the middle average size of your collection. So in many cases, especially when the collections are bigger in size, this may become inefficient. So the question is there any way to speed up a search algorithm to make it faster? And the answer is that perhaps if you do your searches occasionally, not very often, then there is no need to speed it up at all, because any extra steps that you're going to have to make, try to make it faster, are not going to be of your benefit at all, because still, eventually, you're gonna spend the same time. But if you have a collection that really doesn't change too often, or occasionally, you can modify the content of your collection. But if you sort it, every time you modify a collection, if you actually also sort it, this may give you a good boost of performance when you doing your search, because you can then switch to the binary search. The binary search requires that the collection needs to be pre-sorted before you can apply a binary search, which will be much, much faster to execute. So then your focus shifts to sorts, the sort algorithms. So when we populate our array list or linked list, the elements inside are not sorted. They will be organized in exact order as you insert your elements. Remember that add method on ArrayList. We could say add, and it simply will add at the end of your list. Or you can say add and specify a particular position. There's an overloaded method that does that, and it'll be inserting elements at the specified position. So, but ultimately, as you do your insertions or deletions, they will be dictating the order of elements in your collection. So then we can safely say that this is the most of the array lists and linked list type of collections will be unsorted to begin with, because they're populated with data in arbitrary order The user could choose that order, or some other parts of the program will contribute to the order. So the first type of sort, because our challenge suddenly becomes that sort could be very useful, is the selection sort. So the selection sort is based on finding the smallest element in the collection and moving it to the appropriate position. And we have some demonstrations here. Let me save this and start the next segment.